Episode 1, The Hydrological Cycle, River Regimes and Droughts. This audiobook will cover the first 6 lessons of the geography water topic. Information was procured from worksheets, the dedicated water booklet, as well as PowerPoint presentations. Lesson 1, an introduction to the hydrological cycle. The same water that existed on Earth billions of years ago is the same water that exists today. In the 20th century, the world population tripled. By the mid-century, there will be an additional 3 billion people. Most will be born in countries already experiencing water shortages. The use of water has therefore grown by a factor of 6. Moreover, 25 million refugees were displaced, last by contaminated river water. The 7 stages of the water cycle in order are as follows: evaporation, condensation, precipitation, sublimation, transpiration, runoff, and infiltration. Only 2.5% of the world's water is fresh water. 30% of this fresh water is locked in groundwater. 70% of fresh water is frozen in polar regions. Industrialization and population growth are the 2 largest causes of increased demand for water, and the USA consumes the most water per person. Moreover, the agriculture sector accounts for 70% of fresh water consumption, with an additional 22% going to industrial uses. The amount of water on Earth is constant and finite. The hydrological cycle is a closed system as it doesn't have any external inputs or outputs. Its inputs and outputs are balanced, thus meaning nothing is gained or lost. Water in the system changes its form and can be stored in numerous forms, but it cannot leave the hydrosphere and water cannot be added to it. Water is cycled between key stores by a variety of processes at different rates of flux. 2 processes drive the hydrological cycle, namely solar energy and gravitational potential energy. Although water is constantly circulating around the hydrological cycle, each store has a residence time. These residence times vary from 10 days to 15,000 years. Water is considered a renewable resource. There are 2 non-renewable water stores, fossil water and cryosphere. Once fossil water has been extracted and used, it will not be replenished. Similarly, 2/3 of the Earth's fresh water is locked up in the cryosphere, meaning once it melts, water will be released into the hydrological cycle. However, if there is another glacial period, more water will once again become locked in glaciers and ice sheets. Lesson 2, Drainage Basins. A drainage basin is an area of land that is drained by a river and its tributaries. It is separated from neighboring drainage basins by a ridge of highland called a watershed. It is a subsystem within the global hydrological cycle. Drainage basins are sometimes referred to as local hydrological cycles. A drainage basin is an open system, so it is linked to other systems by inputs and outputs. This causes the amount of water in the drainage basin to vary over time. Drainage basins can be any size, from a small stream to a major international river that flows through several countries. Physical factors affecting the drainage basin system: relief. If the land is steeper, there will be faster flows. Vegetation. This increases interception, secondary interception, in other words, undergrowth intercepting water falling from canopy, and infiltration. This then increases evapotranspiration and rainfall. Soil. The type, depth, and porosity of soil affects amount of and rate of infiltration and throughflow. Geology, and more specially, whether it is impermeable or permeable. This affects infiltration or runoff. Porous rocks can store groundwater, such as chalk aquifers, which can also affect the amount and rate of percolation and groundwater flow. Climate. This affects the amount, type, and seasonality of rainfall. This, therefore, affects the amount of evaporation and the surrounding vegetation. Orographic precipitation is produced when moist air is forced to rise over a barrier. The air cools and condenses as it rises and thus rain forms. The leeward slope receives little rain and so forms a rain shadow effect. Orographic rainfall is why the western side of the UK receives the highest rainfall totals. The eastern side has less due to the rain shadow effect. Convectional precipitation occurs when the land is heated by the sun, which then heats air above it. Warm air rises before cooling and condensing. This forms clouds and rain. It is common in tropical areas and is also typical in southeastern England in summer during high temperatures. Rainfall is often intense and associated with thunder and lightning. Cyclonic precipitation appears where two air masses meet. This is called a front. Rainfall is produced when warm air, which is less dense, is forced to rise over cold, denser air. As it rises, the air cools and condenses, forming clouds and rain. This type of rain brings the most rainfall to the UK. Human factors affecting the drainage basin system. Large dams and reservoirs. These delay water movement and add to the amount of water lost through evaporation. Approximately 7% more water is evaporated from the world's reservoirs than is used by people. Over-abstraction. Abstracting too much water from groundwater reserves leads to rivers drying up in times of low rainfall. Deforestation. Forest clearance can accelerate natural hydrological processes. There is less interception, evapotranspiration and infiltration, and more surface runoff and river discharge, but then ultimately less rainfall. A good case study of this would be Amazonia. Over 20% of the forest has been destroyed. In a rainforest, 75% of intercepted water is returned to the atmosphere by evapotranspiration. This reduces to 25% when the forest is clear. This reduces the amount of rainfall and can lead to further degradation. Meanwhile, the amount of surface runoff increases, exacerbating the possibility of severe flooding and mudslides and depleting groundwater stores due to a lack of recharge. Lesson 3. Local water budgets. Water budgets show the annual balance between inputs and outputs. Drainage basin water budgets are usually called water balances. They can either have a positive water balance, where there is a surplus of water balance, where there is a surplus of water, or a negative water balance where there is a deficit of water. You can calculate a water balance using the following formula. T equals D plus E plus or minus S. These are usually presented as graphs showing changes throughout the year. I would recommend looking at the Lesson 3 worksheet for an example of this. Lesson 4, River Regimes and Storm Hydrograph. A river regime is the annual pattern or variation of a river's flow. It is influenced by a number of factors. Size. Larger rivers have more complex regimes resulting from varied catchments. Amount. More rain leads to higher levels of discharge. This can be seasonal. Temperature. Possible meltwater and high rates of evaporation. Altitude. Rivers flowing through high altitudes are most likely to be fed by snowmelt and glacial melt. Geology. Porosity and permeability. Water stored as groundwater in permeable rocks and is gradually released into rivers as base flow, which then keeps the flow more constant. Vegetation. Wetlands hold water and release it slowly into river. Human activities. Dam building can regulate and alter the flow. There are also 3 types of river regime. Ephemeral. This a river that rarely flows, characterized by temporary flow following exceptionally heavy rain or rapid snowmelt. Intermittent. This a semi-permanent river characterized by seasonal flows. Perennial. This a permanent river characterized by continuous flows. A hydrograph is a graph showing changes in the discharge of a river over a short period of time, usually before, during and after a storm. They show how a river responds to a particular storm and display both rainfall and discharge. They are useful for predicting flood risk and comparing drainage basin responses to a heavy precipitation event. Before a storm starts, the main supply of water to a river is through groundwater flow or base flow. However, this changes as soon as the storm starts, as more water flows to the river as surface runoff and through flow. Lesson 5. Physical causes of drought. According to the United Nations, a drought is an extended period of deficient rainfall relative to the average for a region. Because average rainfall varies by location, the length of droughts vary globally. In the UK, this is 15 consecutive days with less than 0.2 millimeters of rain. After all, most droughts are short-term here. In Libya, however, whose droughts are long-term, it's 2 years. There are 4 types of drought, however. The most crucial 3 are meteorological, agricultural, and hydrological, accounting for rain, soil moisture, and rivers, respectively. A meteorological drought is based on the degree of dryness compared to the normal level of precipitation in an area. An agricultural drought occurs when there is an insufficient amount of water for crops to grow, so that they wilt if they are not irrigated. A hydrological drought, then, is quite simply when there is a shortfall of water in a drainage basin. There are 4 primary causes of drought. Cause 1, global atmospheric circulation and the ITCZ. Intense solar radiation is concentrated at the equator. Rising warm air cools and condenses as water vapor to form clouds and rain, a band of low pressure known as the intertropical convergence zone. At 30 degrees north and south of the equator, the air cools and sinks to form a high-pressure belt with hot, dry conditions. At ground-level, air returns to the equator as trade winds, forming the Hadley cell. Trade winds meet at the ITCZ with warmed air rising again. The ITCZ moves seasonally north and south of the equator, causing alternate wet and dry season. The ITCZ is a belt of low-pressure systems near the equator where the trade winds converge. When it migrates north and south of the equator over a year, periods of extreme precipitation are followed by much drier periods in turn. Seasonal variation affects drought risk, e.g. Southeast Asia, has a distinct monsoon wet season. If it fails, there is a real risk of drought conditions. Cause 2, mid-latitude blocking anticyclones. High pressure means sinking air, or, in other words, there is a lack of conditions for precipitation. High-pressure systems in the mid-latitudes bring settled, dry weather that can last several weeks. They are blocking because they force rain, bearing low-pressure depressions to divert either north or south of the UK. Over a few months, normal precipitation levels may fall. This occurred in 2010 and 2012, when southeast England experienced a prolonged drought due to blocking anticyclones. Jet streams are air currents at altitude. Their movement dictates whether cool, wet, dry, or warm conditions dominate the UK, making blocking anticyclones and risky drought conditions more or less likely. Cause 3, ENSO and El Nino. A phenomenon that is known as ENSO, short for El Nino Southern Oscillation, can cause drought, a warming of the ocean surface, or above average sea surface temperatures in the central and eastern tropical Pacific Ocean. Over Indonesia, rainfall tends to become reduced while rainfall increases over the tropical Pacific Ocean. The low-level surface winds, which normally blow from east to west along the equator, instead weaken or, in some cases, start blowing the other direction from west to east. Cause 4, human influences. Climate change is a natural process, but there is also a significant anthropogenic human influence. For example, warmer climates increase water demand and evapotranspiration, putting greater stress on water supplies. Scientists say that severe droughts are no longer a purely natural hazard. There are 3 key human factors. The over-abstraction of water from rivers and groundwater. The reduction of the supply of water downstream through building reservoirs. Finally, deforestation and overgrazing by farm animals has reduced vegetation cover, lowered levels of atmospheric moisture, and reduced infiltration. Lesson 6. Drought case studies. People can make droughts worse and more severe. One example is desertification in the Sahel region of Africa. Desertification is a natural process where once productive land changes and becomes desert. It is reversible. Rainfall in the Sahel is becoming less reliable and vegetation cover begins to die, leaving bare soil. Bare soil is eroded by wind and short, intense bursts of rain that do not allow water to infiltrate. Humans exacerbate drought through over-abstraction, population growth, overgrazing, overcultivation, deforestation, and civil war. For example, crops, livestock, and homes have been deliberately destroyed in Sudan, worsening the problem. Drought is common in Australia, as up to 30% of the country is affected by serious lack of rainfall. There is a clear link to El Niño, as droughts are becoming more frequent and severe. The Big Dry of 2006, for instance, was a 1 in 1,000-year event. Unlike the Sahel, Australia has not followed the same downward spiral of desertification. Careful management of scarce water resources and balancing the competing demands of irrigation and urban populations has helped. The large-scale recycling of grey water and the construction of desalination plants have also helped relieve water pressure. The Pantanal is a large wetland in South America, as 140,000 square kilometers of it lies in Brazil. Its diversity of aquatic and bird life makes it one of the world's most significant freshwater ecosystems. The floodplain is vital and is surrounded by areas with seasonal rainfall. The wildlife therefore depends on a permanent wetland environment. For reference, 80% of the Pantanal floods, but even in dry years, the river is perennial. The drought in Pantanal has increased tree mortality, reduced habitats for wild animals and cattle ranching, severely affected ecotourism, and has incited multiple wildfires. Cattle ranchers set old grass on fire in the dry season to clear ungrazed land, but these deliberate fires can easily spread out of control into the wetlands and forests. This is important as drought causes forest stress and a chain reaction. Younger trees die and reduce the canopy cover, reducing humidity, water vapor, and therefore rainfall. Increasing exposure to sunlight, dying vegetation, lightning storms, and high winds are the perfect recipe for wildfires. After all, trees take 2 to 4 years to recover and lose foliage, which means they can suffer from impaired growth, pests, and diseases. Additionally, it's worth noting that 20% of the Earth's oxygen and fresh water comes from the Amazon. Thankful deforestation dropped by 70% in the year 2000. However, the 3,000-kilometer-long Trans-Amazonian Highway was built to encourage people to settle and farm in the forest. The government has increased the protected area to cover 50% of the Amazon's surface area, and has encouraged sustainable uses for the rainforest, which notably includes rubber tapping and nut farming. They have also increased monitoring. Brazil's current president, Jair Bolsonaro, has decided to increase deforestation efforts in spite of this. This has resulted in 17% of the Amazon being destroyed over the last 50 years. If the rate of deforestation reaches 20 or 25%, the ecosystem might start to collapse.